Hello, everyone. We are going to be starting to look at how we use graphs to represent our data. I have already kind of written in some of the notes in here as well, but I didn't do it all, so we'll see a lot of me adding some of these pieces. But the first thing we're going to learn is how, once we have a graph, what terminology we use to describe that data. The first thing we kind of look at, especially if we're looking at a bar graph or a dot plot or a stem and leaf, is we look to see if we see any peaks. A peak is sometimes referred to as a mode. And when we do go back and talk about mean, median, and mode, it will make more sense. A distribution or a graph that is said to be unimodal if there's a single peak. So something, if it looks something like this. So if this was my data, and let's just kind of visualize a bar graph in here, that would be a unimodal. If we have two humps, it's said to be bimodal. So uni meaning one, like unicycle, bi meaning two, like bicycle or biennial. We could do tri, but they do tend to just lump anything more than two into multimodal. So we kind of count how many peaks we have. If we have a unimodal situation, a lot of times we get a little bit more precise on our classifications. We look for something called symmetry, and you've probably heard that term before, symmetric. That means that if I put a vertical line kind of in the middle or someplace, that I see a rough image of or mirror image from one side to the other. We also can look at unimodals and talk about them being skewed, skewed to the right or positively skewed, skewed to the left or negatively skewed. It is a little bit, takes a little bit of time to get these terminology down. It's not where the peak is located. It's kind of, you're looking for that tail that's going to be pulling the data towards one direction or another. And again, when we go back and talk about the mean and the median and stuff like that, that skewed definition will make more sense as to why we say right skewed or positively skewed. So I did draw a couple pictures here. This one would be negatively skewed because we have some values down on this tail that are pulling the data that direction. It's actually pulling the average down in that direction. So negatively skewed or skewed to the left or left skewed are all ways to kind of write that. This one is kind of a rough picture of something skewed to the right being positively skewed. Now, if we have something that is beautifully symmetric in the middle, it's bell-shaped, is unimodal, that one gets a nice, another special name called normal. This is a curve that we will talk about a lot in this class. The normal curve, again, is one that is unimodal, symmetric, and bell-shaped. If you write the word normal, it automatically implies the other two. So if you say something is roughly normal, you automatically are saying it's unimodal and symmetric as well. So we don't need to put all three of those pieces down. When we are looking at data, also, we aren't going to see perfection. We aren't going to see something that is perfectly normal. We will see things that are roughly normal or roughly symmetric. Sometimes we have that nice perfection, but sometimes we don't. The last piece or last classification is something that happens when we have constant data. So if it's kind of flat, we say that that is uniform, so going straight across the top. So again, in the real world, we are roughly pieces, and we're going to look at some more examples so we can kind of see this in action. So here I have a dot plot. And I've also kind of drawn in the little curve that's there. And so I see the one little hump and I see the symmetry, but I also see that bell shape. So I would say that this is normal. And having said normal, I would not have needed the unimodal or the symmetry. This curve here looks pretty flat. We have some little, ups and downs, but overall, this is roughly uniform. Here I have a single hump, and I also see this tail coming up here. So I see that this is unimodal and it is skewed to the right or positively skewed. Again, I would only state one of those pieces. Which one you choose to use is up to you. Being skewed to the right and positively skewed mean the exact same thing. This is unimodal, even though there's two bars that make up that one hump. If I wanted to think of it as bimodal, we have to have that little gap in between our data. Here is one that looks a little bit normal, not quite perfectly normal. I would love to see some data in this missing piece to be really perfectly normal. But again, real world data is roughly normal. So this one would be roughly normal. Notice I did not add the symmetry or the unimodal. That is automatically implied with my normality. Couple more examples for us just to make sure we kind of see it. Okay, here I see a single hump. I also see this tail coming up to off to the left. So this would be skewed to the left or negatively skewed, whichever way you like to write it, and unimodal. This guy, bimodal. A lot of times with bimodal, we don't talk about symmetry, but you can if you want to. So I would say this is bimodal, and if you wanted to include the symmetry, you certainly could. Here we have a lot of humps. So I'd say about 3 of them. So this would be considered an example of a multimodal distribution. Distribution, that term just kind of means how does the data fall? What does the data look like when we graph it? What shapes do we see? This is an example of a stem and leaf graph. They're a little bit different. We will look at what those are later. The way we read them is we kind of look down the side. So if I turn this one to the side here, you can kind of see the negative values here and the positives. I can kind of put that hump in there. So I do have a unimodal. Now, whether it is normal or skewed, that is kind of a judgment call. And we'd actually need more information to determine if it really was skewed. I'm going to say it probably is, but this one could be also maybe classified as normal, but I would say it's probably more skewed to the left or negatively skewed. So these are the two that I would tend to lean towards, that skewness. Okay, so we have talked about shape. We're now going to kind of look at more specific graphs, like how to construct them. So the first thing that we're going to look at is a bar graph. And when we're looking at a bar graph, I'm going to show you how to draw one in Google Sheets, which is very similar to Excel. I don't have Excel on this particular computer, so that's why I'm going to be using Google Sheets. But a bar graph is used to show frequency. So when we're trying to show how many in a certain category, we tend to use a bar graph. When you are graphing data, no matter what types of graphs you are using, some things you should always have, although my graphs did not, is a good title. And what I mean by a good title, it will represent the data. It will tell the reader what they're looking at. If you know the source of the data, a lot of times somewhere in the graph, you will put that source. Also, your pieces of your graphs should be labeled with scales or labels like what they represented. Like here, we have that these numbers represented the frequency. These numbers here represented the percent who vote for a certain candidate. Even if you have labels or scales that make perfect sense, like maybe I had January, February, March, April, May, June, July, which are months, you might want to tell the reader what year we're actually talking about. So you still would want to have a label as well. So make sure you have both the scales and the labels. Okay. The other graph I'm going to actually graph right away when I jump to Excel is a pie chart. And a pie chart or a circle graph, that's another way to classify them. I think they're trying to get away from the word pie. Some textbooks will use circle graphs. Some will use circle charts, graphs, charts, intermixable, depending on who you're talking to. But pie charts or circle graphs or circle charts are used to show percentages in a certain category. So not the number of, although you can include that if you'd like, but we do want to make sure to have the percentages in there. So at this time, I'm going to kind of jump to my Excel, my Google spreadsheet here. So give me one moment to share something else. There it is. All right. So what I put in here right now, I entered this earlier, is I just entered the data from our module 5, the earthquake data. So this was the strength of the earthquake and the count that we had. So very easy to draw graphs of certain types. I'm not going to say all types of graphs are easy to draw using technology. Some of them are, some of them are not. This bar graphs and pie charts, since they are probably the most common, also line graphs as well, very easy to do. So once you have your data entered, I'm just going to highlight that data. And then I go up to this insert button. So I'm in Google Sheets. The steps are pretty much the same, except when you're in an Excel spreadsheet, when you hit the insert, you're going to actually get this chart area show up on the top. So there'll be like a little spot up here that has all these different charts for you. In Google Sheets, you hit on the chart, it just automatically goes to, for this one, it automatically went to the pie chart. Notice it also automatically put in your percentages for us. So very easy to do. Things it did not do was add a title. So well, it has a title. You want to make a better title. This is representing earthquake strength. So you might want to actually put that in as your pie chart title. So again, very easy to do in Google Sheets. You enter your data into the spreadsheet. I went to insert and got my nice pie chart. If I wanted a different chart, there is your little setup piece over here. You can do a bar graph as well. So here's my bar graph. Notice it did do the strength and the count. And again, the title is very generic based on what I typed in. So we're going to want to make sure to include a better title on that. Okay. Again, and you can change things like here, down here, it does say what you can change your axes and your series. That's the count here. So if you wanted it to say something differently, you can just go right in here and change it. Okay. I'm just going to be doing a few more quick things in this video. And then I'm going to stop this video to make it a little bit shorter. But I'm going to go back to my document camera, I hope. And just show you a couple more examples of some more bar graphs. I'm not actually going to create them, but we'll find it, just show them to you as examples. So hopefully this comes up relatively quickly. There it is. Okay, so here's an example comparing. So we're going to have two sets of data and some ways we can compare our data. So you can do what they say side-by-side graphs. So notice some things to notice is it is very easy to compare your two data sets, your 2 years, so 1995 and the 2015. Very easy to tell them apart. They have the ratings here, your percentage. One thing it's doesn't have is a nice title. So some things that I'm seeing, no title. We can notice that PG-13, a lot of PG-13 percentages in 2015 compared to the 1995. A lot less R-rated movies in 2015. So in other words, they were kind of backing off on whatever made things R-rated. So those are just some things we can kind of see. When you're doing comparison graphs like this, you do want to make sure that you can tell very easily the difference of your two bars. So which class went to what. And if you have three, same thing. You want to be able to distinguish which group is which very easily. We also can do what we call a segmented bar or a stacked bar. So this is kind of like for percentages. And this is one way to kind of compare pie charts because we're looking at two roughly pie chart-ish in stacked form. I find these a little bit harder to determine, especially if you had more categories, because then those middle categories, it's really hard to tell which ones are bigger and smaller. So here I can easily see that boys like pizza more than the girls did. The girls like the hamburgers more than the boys did, and the hot dogs about even. But if I had more categories, a little bit harder to see. So it is a graph that is out there. It is not my favorite, but some people really do like to use these stacked pieces, especially if you're doing like comparing percentages from one group to another group. So instead of having like side by side pie charts, which would be even harder um, to compare, these are a little bit easier to compare than two different pie charts. So. Okay, I am going to stop this video here just to make it a little shorter. I will continue with some other stuff in another video. So hopefully this is starting to make a little bit more sense. I know we have gotten a lot of terminology in a short amount of time. So hopefully you are spending some extra time working with the terminology to get used to it. Again, if you have any questions, feel free to make sure to contact me. I look forward to seeing you in the next video. Have a great day.